Hi, welcome to Basilisk 2. So this web page actually explains to you the basic processes that are needed to upgrade modules, C or C++ modules from Basilisk 1 to the new Basilisk 2 system. In particular, most of the changes are already because of the new messaging system. So again, as with the changes to the Python code, where all the existing functionality in 1 is retained in 2, it's just different syntax and how we do it, and typically less lines of code. You will find the same to be true here. We can still check if a message is connected. We can read a message. We can write a message. We can zero the message data, make a copy of that stuff. All the steps are there, but it's going to be actually simpler. So the purpose of this video now is to quickly give some highlights. You've just read this. This is going to go through the content quickly, just giving you some takeaway messages for different sections. And then we're going to jump into code where I'm going to show you a C module that I converted and a C++ module, just to give you an idea that having read this, this is what it actually took to upgrade a module, which really wasn't that bad. So go through it. Okay, message names, go see the conversion of Python stuff, because I already talked about how the message names, something that was called state out message name is now just become state out message, and modules that weren't compliant with Basilisk naming conventions have been renamed and message names have been redone to be compliant. That's all in this script here, migrating 1 to 2. And so see that for that one. Creating new message is you can go there, and if you're making a module and you have your own messages, for example, you used to put them into flight software messages, or simulation sim messages, or simulation, what was it, sim interface messages, something was a long name, I forgot it already, right? You had to somehow decide, is it used only in flight software, only in sim, or in both, in which case it was an interface. It's a little confusing, that distinction, because as soon as one other module uses it in flight software, then a sim message becomes an interface message, and we have to rename everything. So we got rid of this nonsense and just said, look, it's all just a message. So now if you have messages, as before, you can look at the sample here. You have a C structure type definition. And the only thing that's changed is, before we would call it FSW message for flight software, or sim message, or int message for interface. Now we just call it message, but we do append payload at the end to distinguish it. This is really the data of the message, because these message objects have both header information and data. Here we're specifying the message data, the payload. So you can create that. You can make one of these H files. Now, where do you put them? They're all located now centrally inside source, architecture, message, payload, definition, C. That's where you drop them. There's a very few number of message definitions that actually require C++ currently, but if you have such one, it's in almost the same folder. It's just a neighboring folder called message payload definition CPP, and that's where you would put that .h file. And the file name uses upper camel case. Yes, so I'm starting. Okay, so the file name itself, when you define it, I'm not sure. Oh, here I have an example. That's what I was looking for. This is live. So if you have some sensor message payload.h, it should start out with a capital letter with this stuff. Same as we do here. This should match. So the file name capitalization should match in the structure. That's kind of what's expected. Now, when you put it in there and you run your typical Python 3 Conan file with whatever other arguments you want to do, it actually checks these folders, and then it automatically creates the C wrapping, so C modules can access C messages. C modules won't be able to access C++ messages, which kind of makes sense. They can't do that. So CPP messages are not wrapped with C code, but the C messages are. So they're available both for C++ and C. C++ uses template classes, so those get automatically created for every one of those C messages and CPP messages. So that's what this one line does, all for you. Okay, so that was messages. Let's go back to actually upgrading modules. We're going to start out first with imports, some general import things. What has changed is, before you could write your import statements relative to source, relative to simulation, relative to flight software algorithms, and it wasn't always sure. Sometimes there's a utility in flight software, there's a utility in simulation. Which one did you mean? And I mean, the code worked, but to make it easier, we've actually gotten rid of the stuff where now everything, you no longer have things relative to simulation of flight software. All the paths should be included relative to source, because that way you see right away, where is that file and how do I get access to it? So you might have to update that to work. This one has actually moved because this folder has vanished. Macro definitions are now defined under simulation utilities. So if you have that inclusion, you have to update that include statement. And you can see here, this was something relative to simulation implicitly. Now it's done explicitly to make that. So if you see some errors all of a sudden, oh, I can't find this file, just make sure you put in the proper full path name. That makes life easier. Okay, that's it. Now we're going to go through C modules first, then we'll go through C++ modules. So with C modules, all the includes had this one line that said, hey, includes the static underscore messaging.8. That was really the C interface to the old bulletin board style messaging system. So we no longer have that, so you can just nuke this line. You don't need that anymore. Instead, we have to include specifically these automatically wrapped C interface files to these message definitions, these .h files that we saw earlier. And that's done with this line. So for every message that you need to use, you do an include from C message, C interface, right? You include this, whatever it's going to be, attitude guidance message. And then you can see it ends with underscore C. This way, you're actually pulling the full header payload. It's the message object definition. It includes the payload definition, so we don't have to pull that one in separately. This one line will do everything you need in C code. Cool. Now that we have this is good actually to create in C. You have this definition that attitude navigation message underscore C. That's the smart message object in C. It can act both as an input and an output message. In C++, that's different. You will see we have very dedicated output message objects and then input message readers that we do, but we can't do those kinds of things in C. So we just have this object, and by the naming convention, you're telling yourself, now that's an out object. So we still expect to every module name that's outputting something should end with out message. Every input message should end with in message, similar as before. Flight software, int, sim, those distinctions. Sometimes there was a out flight software message or something, or sim out message. Those sim flight software ints are gone. So that just makes it easier. If you want to make an array, you can easily do that. We have sometimes, you can have 10 different sensors messages that you have to bring in. So as before, you would have something out. I usually write out message is just an extra S. An S shows me this is an array, and in C++ it'll be a vector of messages. But this type definition dot something square brackets an array, and off you go. Very, very straightforward. Now you have an array of these message objects. CrossInit you can remove. We no longer need that because all the subscriptions happens in Python. We no longer need the CrossInit step to cross-initialize across modules. So that part you can just chunk. If you had code in CrossInit that did anything other than just cross-initialization, move that to reset. If you had code that, for example, set some variables, the number of wheels or whatever, in CrossInit, that shouldn't have been there to begin with. Put that into reset. The SelfInit function is still needed in C, but it should be simplified. And it should only be used to initialize the output message. And I'm going to show you that right below. That's the only thing it should be doing. Everything else, if there's stuff in there that sets variables to 3 by default on SelfInit, that should be in reset. Because then every time we call reset, it should reset that back to those values. Okay, so CrossInit, nuked, SelfInit should only have what I'm about to show you. So we used to have all these lines in SelfInit to create in the messaging bulletin board in Basilisk 1 an output message. You had to give it a name, and you had to give the size of the message, and you had to give it the string of the message type. And if you got this wrong, good luck, because it would just silently fail, and you'd be writing too many bytes, too little bytes, weird things happened. With the new system, all you have to do is, if you have a message that's of type module message, like an attitude guidance message, this is one of those automatically wrapped C functions that was created for you at the beginning. So then you would just write attitude guidance message _ C _ init. And that will initialize it. And essentially what this does is the smart message has payload payload for this message structure. It has a header variables, and then it has pointers to such things. And if it's going to write to itself, it just points it to itself. That's all it's doing in that initialization. But in C++, we don't need this because constructors can handle this function. But in C, we have to do it. So that's the one thing you have to put into the SelfInit in a C module. Make this initialization only on your output messages. Don't have to do this on input messages. The connections there are actually done in Python when you subscribe to stuff. But here we have to do it. Okay, so that's it for SelfInit. Now, if you have other things you can do, let's say you want to check if something is linked, you would again have this added, whatever the message type is. For example, attitude guidance message, @guide message _C _ linked is your command. And then you provide it the pointer to your message. So as before, all our variables in C modules are stored inside the config data structure. And so this gives it the pointer and it'll check. If you give it a pointer to a message object that is of different type than what this function is checking, it will complain to you at compile time. That is a beautiful thing. Because here, if you got anything off, it would just compile and good luck hunting down why it went wrong. Here at compile time, if you basically try to check with this method, if an attitude is linked method and you're checking if a planet state message is linked, that doesn't make sense, right? And at compile time, you'll get errors and go, oh yeah, I copied and pasted something wrong. So strong type checking, we love it. To connect input messages, this was basically the CrossInit. Inside CrossInit, you probably had a lot of code like this, subscribe to this stuff, right? And you had to get all these things just right. All of that is gone, no longer needed. We're doing peer-to-peer connections. And in Python, you tell it, this output message connects to this input message. So that is really cool. Let's see, creating local copies, very similar as before. When you pull it in, when you included module message _ C.h, let's see, we did this at the beginning. Here, you actually automatically also include the payload definition. And that's what we can need here. So let's say you have to make a variable that you want to go, I want to read a copy, which we typically call a buffer variable. So I'm reading a message. I need something to put that message into in my subroutine. So before it would be called attitude guides, flight software message. Now it's called attitude guidance message payload. So slight naming change. And then the variable name. And that's it. To read a message, what we'd have to do is declare this buffer variable, so we have something to put it into. We would zero this, typically with a memset, which is always dangerous because, again, if you do copy and paste and put the wrong message type in here, it would just zero a bunch of stuff. And, and then you spend days trying to figure out why is your code not working. So we no longer need that. And then to read the message, there's all this stuff, which quite frankly, I never remembered. I always had to go copy paste from another example on how to do that. Now that's going to be replaced with, the first step is the same, except for here, you will see we slightly changed, the message name is now message payload instead of sim message or something, but that gives us that data structure. And now we want to read. So we use these wrapped methods called read. So attitude guidance message _ C _ read, and you give it a pointer to your input message, and it will go read from that one, grab the data, and give you a copy of the structure of that input message. So not the header, not is it written or something. It's actually going to return to you now the actual data of that message, and we'll put it into message buffer. So just compare that quickly to all these lines here, especially this function. Have to remember, this is so much easier. You notice we're not zeroing the message. Because we're going to get a copy of whatever this input message module has, you don't have to zero. It's just going to be overwritten by whatever is in there. And it's really the responsibility of the output message generator to make sure things are properly initialized. And in fact, when you create messages in Python, in C, or in C++, even in modules, everything is set up right now to initialize your message content, all the data, to 0 on default. and then you write it and do stuff. So anyway, that's why that zeroing of read messages step is just not needed anymore. So if you want to check if something's linked, you would have, the whatever the message name is, attitude guidance message _C is linked. If you want to read and check if it has been written, you call this command. This will check the header of that input message and tell you, yes, somebody has actually written this once. This is not just default values. If you want to get the time the message was written, there's this method. So these are all functionalities. Before you had to pull out of the header that came out of this read statement and pull it all out. Now we have really quick interfaces to it. You can also get the module ID if you care, who wrote this message. And that's it. Now zeroing, you've seen before, we do the zero command with memsets. Very dangerous if you get anything wrong. Now there's an easier way to zero a message. If you create a copy, so we have some message payload, right? Just makes a structure definition and it gives you some message buffer. This is a variable, but I want to set it all to 0. This is very common with output messages. We have an output message buffer, and before we populate it, we just want to 0 the whole thing to make sure everything's 0 now, and then start populating it. So here you're just creating this in code. So it's your responsibility to make sure everything is zeroed. You could do a memset, but the recommended way is when we're wrapping this is linked, is written, time written, and everything methods, we also actually automatically created a 0 message payload function for each of the message types. So if this was attitude guidance message _C _0 message payload, this function returns a zeroed message copy to you. And this is an easy way to just now 0 your stuff. And again, if you copied and pasted and fat fingered something, you're going to get compile errors and says, look, you're trying to give a zeroed spacecraft state message and put it into an attitude guidance message buffer. That doesn't work, right? The strong type checking is really, really nice. Good, so that's how we make zeroed buffers. To write to an output message in C, this is where you can see the code. Before we would 0 stuff with memsets, that's what we can do now more easily with this 0 message payload. So that's actually nice and safer. You then, create the input, just the variables, and you do all your math and set up what is the message that you're spitting out, right? So that's the same process before and after. But then writing the message was this long thing, and you'd have to have size off and have this weird stuff here, and you have to give it this ID. And if anything's off, it would work, but you gave it the wrong ID and you're writing the wrong pointer, and it just takes it and writes something. And so good luck debugging that. That was tricky. It was fast, it worked, but it was tricky. With the new system, the write function now, that's also an auto-wrapped C function around your message type. So if this is an attitude guidance, that's always my example besides module message. If it's attitude guidance message _C _write, the first one is a pointer towards your data that you want to write. So that's the output message buffer. That's similar to before. That used to be this here, but we don't need to have this void and other magic going on. It's just a pointer. And then the next thing is, to what message do you want to write this to? So this is your output message, and you give it the pointer to your output message. And the module ID, that's part of your method. We provide that as before, and we provide the call time as before. So this message will have that embedded in its header. This was written at this time, and this module wrote this message, right? But you can see this is actually quite a bit more logical and simple than what we used to have. And there's not this magic code that you better get right or something doesn't compile. And the big thing is, if you have 6 different output messages and for some reason you fat fingered and you put the wrong message structure into the wrong message type, it's going to complain at compile time. Strong type checking. That's cool. Okay, now we have the H file, we have the C file updated. The other one you need to update is your I file, your Swig interface file. We used to have some gen size off stuff because of just the way we created messages and had to write them out and do all that. None of that's needed with this new messaging system. The size of the stuff is implicitly done within the system. So not needed, you can delete those. Doesn't hurt if you have them, but it's not needed. Next, includes. Make sure you update the paths to be absolute relative to source if needed. But if you have a particular message type, it would be under architecture, message payload, C, this is a C message, and I would give it this. This will create the C interface. So your module, in Python, you can say this module dot this message equals something, subscribe. So that's easy. And the one extra line is this one. if you run into errors where your code is working, no errors, but every time you read in a message, it's all zeros. Even though you set it in Python you set the message to be 1, and then you read it in C and it's 0, you may have forgotten this step. This extra line is really critical there. It will compile, not give an error if you don't have it, but it won't work. So whatever the message name was, attitude guide message payload, you would then add here attitude guide message underscore C with a struct in front of it. And you'll see lots of examples. Okay, so that's one of the updates. Some modules have custom stuff. They may have arrays of these different message types, and those are swigged in there. You can keep that. You can also, if it's something that's used commonly, some of them I moved into messaging.eye. That way in messaging, I just have them. I don't have to remember which module has the swig interface created. If it's something that only this module keeps, then I would say leave it in the module. It doesn't have to be in messaging.eye, you know, because it's just only this module will ever use this thing. But otherwise, if there's something like a vector of spice messages, well, that's something lots of modules actually use. All of that we moved into the messaging.eye swig interface, and you'll see it in there. Okay. If you want to create an array, there are some modules that have array of sensor messages or something. That's where you have to still add struct list, and that's particular for this module, so that would still stay in there. But you may have to update this to be an array of these message types. So it would be attitude guidance messages underscore C. There's some minor editing you'd have to do for that one. The rest is, yeah, the swig common architecture where you're pulling it in because that's moved to architectures, no longer inside simulation. Just do from Basilisk architecture.swig module import. That was the one line change. That's it. RST documentation, I do expect, you know, it'd be nice to have it fully fledged guide and everything, but there should be at least a basic introduction, like what is this executive summary, what's this module about, and there should be that table of input output messages that specify the message object name, the message object type, and also what, you know, a documentation string. What does it do? Is it optional? Is it required? All that stuff. That's it for CMS modules. C++, very similar, syntax is slightly different. So here, for example, when we included something before, we may have, we have to change the include statement slightly. If you want to include now the message, a C message, you can do it this way, from architecture, message payload def C, some message payload, you know, whatever that is, attitude guidance message payload.h. That's what you import in your .h file for the module. If you're including a CPP, you know, C++ modules can have C++ messages, then obviously the path has to change slightly because it's a different folder that has these .h message definitions. So pretty trivial. The old messaging system, this is what we used to include. This gave us access to the messaging to create messages, to subscribe to messages, to read to messages, to write to messages. You can replace this line, and the new messaging system is called messaging. And so in C++, you do include this line in your .h file. This pulls in your messaging system to create this stuff. Because in C++, the messages, they're different from C. C, we had to do, we can't do some of the niceties that we have in C++ and C. So we wanted to make as nice a C++ message object as we can, but also make them function with C. So C had to be slightly different. But the cross connections, the translations, it's all under the hood. It's pretty seamless. So pull in this messaging. Now, next, SelfInit and CrossInit. There's no need for a C++ module to have SelfInit because the output messages will automatically be able to write to themselves. This happens in the constructions of these messages. That's not needed. And CrossInit, cross initializations, as with C modules, no longer needed. So get rid of all of these. In fact, CrossInit no longer exists. SelfInit still exists if you have one, but it shouldn't be there in C++. There's no need for it there. And so you can get rid of it. Any other code that was doing things besides creating and cross-initializing messages should be moved to reset method. And that's been done for all the Basilisk modules. And then in the .h file, somewhere you would define your module out name before in Basilisk 1 as a string and your module ID as an integer with public variables. You can delete all of those. That's no longer needed. If you're making an output message, This is where messaging has to get included. This is your template class that basically creates this module, this output message object. It's a C++ class instance, but created through a template class. So you type message, and then you got these less than, greater than symbols, the bracket, and then this is the output message payload. So this would be like attitude guidance message payload, and this would create your module out message name, this variable name. So we'll see that in the code. This is how we make output messages. For input messages, again, no longer need strings and IDs, but we have read functors, actually. So these are reading classes that can specifically connect to these message classes. And so the input message is really a read functor. So that's set up. So instead of module in message name, you have module in. Instead of being a string, you make it a read functor with the less than, greater than symbols, and then of type of whatever this message is, attitude guidance message payload or something. This will create a read object that can connect to this attitude guidance message out object with all the type checking. And the syntax will be even easier than C. Let's see, if you want to make a vector of these, if you have a vector of output messages, for example, this happens sometimes, you can do that, but you want to make a vector of output message pointers. So there's still out messages, like with arrays of C output messages that we had in C objects. In C++, we tend to have vectors, not arrays. So you can do that here, but this asterisk is important because it creates an array of pointers to these output messages. And I'll show you below in a second where those get created. But that's how we make vectors of these things. Now, that's it for the .h file. Now we get into the CPP file, you know, where you typically do SelfInit, CrossInit, create, subscribe, read, write messages. What updates there? So old code like here, this is in SelfInit. You can basically get rid of all of this. You don't need to do that. When you create this message object here, that's all it needs. And it's its own constructor. It knows how to connect to itself. It's all done. It's one shot done. So SelfInit really isn't needed. There shouldn't be a SelfInit. CrossInit as well. You can get rid of it. I think I'll talk about that down here. When you subscribe to messages, all this kind of code and you can just delete. You no longer need that. All this functionality is done in Python. If you're creating an output, if your output is a vector of messages, then somewhere in the code, you're going to have to add something like there are some magnetic fields, or I can add several spacecraft. So per spacecraft I add, I need to append to my vector of output messages another one. And I'm creating these objects every time the user calls add spacecraft to model. You know, that's an example of that, for example. So if you go look at that code, the way you do that then is you create a pointer to this message object. And then here you create an instance. The key is the new command. This makes a new one. And it doesn't get, its memory doesn't get released just because you exit this method. So that was a key thing. And then so this message gets created with its memory here. And then I am pushing back, and this is just a pointer MSG. I'm pushing the pointer onto the vector of output messages, right? And that's what we do. If you create this, of course, here, don't forget in the deconstructor, you need to also loop over your vector and free up those, memories that you created with new. So if you know C++, this should be a standard thing. Anyway, that's how we make vectors of output messages. There's a lot of things you can check. There's linked, I'll discuss below. But if you want to subscribe to, this is CrossInit. Again, all this code you can just delete. All that functionality is not needed. CrossInit should be gone. And you cross-connect things in Python now with Basilisk 2. That's where everything is set up explicitly. To read code, this gets interesting again, right? Before, this is Basilisk 1, we had to do all this stuff. You'd create some input flight software message, and give it a name. Then you had to zero it with this dangerous memset, and then you have to have all this code and remember what to write. Good luck, to do all of this. This gets replaced with slightly modified. Instead of input flight software message as a type, we would have input message payload. So this could be attitude guidance message payload is the type, and then you make your buffer. So minor edit. And all of the rest of the stuff, all this stuff here gets replaced with this one line. Again, this is the beauty of C++. This input message, this read functor, you simply call that read functor with empty brackets, and it will return a copy of whatever it's connected to. It will pull that data, give you that structure, and give you a complete copy and put it inside this thing. So that's where I do want to take a second to marvel at the simplicity of this message reading compared to the old one. This is so much easier. And again, the beauty is this is all done now with strong type checking. If you fat finger something and you have a planet state message being read in and put into a payload of a added to guidance message, at compile time, it's going to yell and scream at you and say, no, error, you cannot do that. And so this will make it much easier to go, ooh, wait, I didn't copy something correctly. So anyway, same as with C, strong type checking, but very, very simple syntax. Because these message objects are C classes now, they will contain the header and payload and the pointers and does all this magic under the hood. To figure out, has this input message ever been linked? Because sometimes we have optional stuff, right? If somebody's connected this planet state, then use it. If not, don't, or default to something that's prescribed. So in C, we had to do the message type. There was a method called message type _C _ is linked. And in C++, we can simplify this and just do the input message dot is linked. And that'll return you 0 or 1 and say, yep, it's linked, or no, it's not linked. Has it ever been written? It's just dot is written. Has it, at what time has it been written? You do dot time written. And if you want to pull the message module, who wrote this message, it's the model ID. Like in C, it's just actually simpler in C++. So that's really cool. If you want to zero things, these message objects, these output messages, because it's our responsibility to zero the output buffer. And it's a really good practice still that you create your output, message data with this, and you should zero it first and then populate it. Because that way, if somebody else adds another variable to this message, your module will still work and not just give random memory because nobody ever wrote this variable. It'll just be zeroed by default because maybe you don't have it. Some modules are only gravity only cares about position. It doesn't care about velocity. If somebody adds accelerations and third and fourth derivatives, fine, I don't care. But I should always return a message that has them properly zeroed. So that's your responsibility. So you can do that. You could actually in C++ define this structure, then equals squiggly brackets, that would zero it. But I like this one because it's very explicit and does it with type checking. You can also say the sum buffer is the output buffer dot zero message payload. Like with C, it'll return a zeroed copy of the structure. And that's a safe way to zero a particular message data variable that you have. So, okay, we're getting close to write to the output message before, again, all this magic code. I mean, good grief, who remembers this reinterpret cast with a new uint 8 _ t star space bracket ampersand out message buffer and so forth. I never remember that. I copied and pasted it and went there. The new code, very simple. Your output message that you've now defined in your class, in your module class, there's a method called .write. And like with the C code, we have to give it a pointer when writing to the data structure. That's what you defined up here. You give it a pointer there. We don't have to tell it what to write to because that's embedded now in this object. So we just tell it, this is the data that I want to write to my module out message. And you give it the ID of yourself, of the module, and you write the clock time. And this writes everything. Again, stop and marvel. This is so much easier, so much simpler. And if you fat finger something here, it's going to yell and scream at compile time. Whereas before, if you put in the wrong buffer, the pointer to something, it would work. But who knows what you're writing and you're wondering, why on earth does this data not make sense? Now you will know right away at compile time. So this is really cool. The rest of it, imports, we already talked about, like we see some of these things have changed location. So simulation swig model is now architecture.swig model. Gen size you can get rid of, that's easy. The includes, before we included messages like this, sim messages or something. Now, like in C, we have to actually bring in from architecture the message file. If it's C or CPP, you just replace it like you show here. And if it's a C message, you still have to include this one struct. If it is a CPP message, the struct actually is not needed, but it is needed if it is a C message. So anyway, that's the differences. And as before, we have things that are swigged for interfaces. Some of it might make sense moving to MessagingEye if it's used by lots of modules. If it's only used by this module, you can leave it in there. If you have a message of output a vector of output messages, I should say, you do need to create something like this. Again, you could put it in your own if you're only one using it, but other ones like, vectors of spacecraft state messages, there's lots of modules that use it. I put that into the messaging.eye, but that's where you have to declare in Swig, tell it how to interpret that from Python so we can access it, because otherwise from Python you try to connect to these message vectors elements and it'll tell you, I don't know what this thing is. So that line is important as before. It's just now it's a vector of message pointers. And then the update. So cool, this took a little bit, but hopefully some highlights after reading this that kind of help you understand this is what it's going to take to update modules to work in Basilisk 2. And now let's look at some quick examples. We're going to go switch over to screen sharing quickly to work on Xcode. So I have here, those are my dogs. I have here an example that I'm showing, like flight software. We use the 3-axis magnetometer communication module. It's an easy one. That really focuses a lot on the messaging. It has input-output messaging. What all did I have to change? Old Basilisk 1 code is on the right-hand side, actually, and Basilisk 2 code is on the left-hand side. You will typically find the stuff on the right is more verbose than the one on the left. So what did we have to do here? In the .h, you can see the static messaging we just get rid of. We don't need that in a C module. Everything's embedded in these smart things. And then I was cleaning up which messages are actually needed. And so instead of including the TAM sensor body flight software message, I am now including TAM sensor body message _C. It's always this _C. That's what you need to get the C message object things that we created. Otherwise logging, everything's the same. So all of these get simplified just to this. Now inside, we had these message names that were character strings. All of that's gone. I kept the same object name. So tam in message name becomes tam in message, but it's not a string. It is actually this smart message object in C. So tam sensor message _C. That's what we had. And again, input message and output message really have the same. There's no distinctions when you import or create them. It's how you use them that defines if it's an import or output. And your local copy, I just had to change IDs. Sorry, IDs you can see I got rid of, just I don't need them. And then here I had a variable in the structure that would give me a copy of the sensor data. And so here I just had to update the type because we no longer have flight software message like it was defined right here, FSW message. It is now just a message and payload. That's what we call them, these new message types. So that's the .h. Let's go to here, the .c file. I'm going to switch so it compares against my developed version. There we go. What did we have to change? Up here includes mostly the paths. We want to make sure that they work. Sensor interface is nice, but now it has to work relative to source. So I have to add flight software algorithms, and simulation utilities linear algebra is now architecture utilities linear algebra. That's where it moved actually. All those utilities are inside architecture, those linear algebra, macro definitions, all of that stuff. So you can see the imports, how they changed, easy. Here, SelfInit for the C module, I had to create all this code to make a message and not fat finger anything. Now, as I created that smart message object, the only thing I have to do in the C code is tam sensor body message type, right, _C_init to connect to itself. It's basically what the C++ constructor does with C++ modules, but I'm doing it in C. So that's why we still have a SelfInit on some modules. So that's the SelfInit. CrossInit, just before cross initialized, I just nuked that function and got rid of it completely. Reset, nothing was required to change. The only thing I did do, which is kind of nice, we tried to go through all the modules and see what are required messages. And we're now checking in reset if a required message is not connected. So if it's not linked, then I'm throwing out a verbose error saying, hey, you didn't connect the required message. We did that for convenience. So as you're doing it now, connecting these different things, we no longer have implicit names. You have to explicitly connect something. And if you miss one of them, at least you will get an error message that's useful. This module, it's this, this particular input message was never connected. And that helps you track down what you might have missed. The rest of it is, in this update, we read and we write. So before we had to define all the message header stuff and then do all this zeroing and reading with lots of code. Then we do our math, which here is very trivial, and then we write it, right? So here I'm creating a copy basically of my reading buffer. I called it local import. So I updated the variable name to work. Then instead of all this stuff, I didn't have to zero because I'm just getting a copy of whatever is here with this read method. Very simple. That gives me that copy. Then in the module, you do all your math, and then writing, instead of this stuff, I have this method for this, the output messages of type temp, sensor, body, message. So then I add _c _write, give it the pointer of what I'm writing, give it the pointer of the output message that I'm writing to, module ID and call time. Pretty easy to remember. That's it for a C module. This is all I had to do to update it. Let's go look at the C++ module. So I'm going to use magnetometer and do a comparison from Basilisk 2 back to what Basilisk 1 was doing. So the includes, the paths, again, are relative to source. So they're slightly more verbose, but I think it's much more human readable. You'll know right away, oh, that's where that file is. And instead of including stuff from sim messages, that folder no longer exists. Everything gets included from architecture, message, payload, def that we have, right? And you go from there. And this is the other line. For C++, you do need to include the messaging because it uses that to create these templated message objects that we interface with. The rest of it is just adjusting the paths. They're pretty trivial. SelfInit, if you look on the right-hand side, and CrossInit, those methods have been nuked. We no longer need them. C++ modules just need to have a reset method. And where before we had a state interface message name, now it's just called state in message, and not being a string, it's an input message, so it's a read functor, and I have to provide it the right type. So this one reads in a spacecraft state, so it has a type spacecraft plus states message payload. That's the .h message definition. There's a second input message that reads in a magnetic field, and it has a different type, right? But it's also a read functor, so that's an input message. Whereas the output message ends with out message, I use the message template class and give it the same payload definition. It has a 3-axis magnetometer sensor message payload, and this creates that object, initializes it, does a lot of stuff under the hood. You're just done. That's all you have to do. Looking down, the IDs you can get rid of. We don't need these IDs anymore. And if you have local copies that you want to keep track of message that you read in, just be sure to update the names because we no longer have sim message and flight software message. It's just message payload now. So just have to be a quick edit. But you can see this is pretty easy to do this. Now, finally, we're almost there. C++, I'm going to go through this one, compare from Basilisk 2, which is on the left, Basilisk 1 on the right. Includes, again, everything's relative to source, so they just become slightly more verbose. And all these support libraries that were in simulation utilities are now actually in architecture utilities. It's a better place where they're supposed to be. So that's pretty trivial. Then we see output buffer count. Those variables all had to do with the old messaging system, message IDs, default message names, all of that we used to do. Zero it, delete it, get rid of it. Don't need it anymore. Okay, so that's simplified. Moving on. Let's see. Now we have the SelfInit and the CrossInit. That the SelfInit had to before in Basilisk 1 create its output messages and do that. Not needed anymore. This is done automatically now when you connect things and create these messages in Python or in the module. CrossInit, all it did was cross initialize and connect to other stuff if they're connected and check that they were connected. All of that is deleted. But it did check, for example, here, you can see it was checking if this was a required input message. If you didn't specify it, it yelled and screamed at you to give you help, going, hey, you should have set that. So that functionality has moved to here, right? I've moved that here where I'm checking this input message, has it been linked, because it's a required. And if not, I yell and scream and say, look, this hasn't been connected. And the same with the state input message for the spacecraft, that's also required. So this is an example where functionality that was in CrossInit, I moved it into the reset function, and I got rid of CrossInit, I got rid of SelfInit. There was nothing needed. Moving on, here we read in input messages. You know, before we'd have the local headers, you have to create them separately because they got returned, and then you pull them. Now the message objects, that's all contained in the object. You don't need to do all this extra stuff. So all these lines of code from here to here is really replaced with this one single line. Isn't that beautiful? You know, I've got an input message, read functor. So I call that read functor, and it will go do its thing and give me back a copy of the message data structure. And this happens to be stored here in a local class variable. So in a one-liner, I replace all that stuff on the right-hand side. And I need to read in a second one. So all this other stuff where you had to zero and do things and call all this code, this is what I'm doing here. Super simple now, and with strong type checking. If I would try to set the mag data into a spacecraft state, it would yell at me at compile time. Don't do that. Just very nice. Okay. There's some minor edits I did on variable naming. We can ignore those here. But writing messages, this is something that's messaging related again. The local copy, I have to it's no longer called sim message, but message payload. So I updated that. I need to zero it. So I'm using this handy function here that does strong type checking and that everything is good, versus this one, which is very dangerous. So that's an improvement. Then we copied stuff over, that's cool. But then writing again, you had to call all this stuff, and good grief, who remembers all this stuff, to write the message. Now you simply go to the message object that you've stashed in your class, tam out message dot write, give it a pointer of what to write, give it your own module ID, and give it the clock that was provided to this output message thing. And that's it. And we're done. So I hope this gives you a quick sense of what all has changed. It takes a little bit of work to do it, but it's pretty mechanical. And for the most part, like in particular here, things become so much simpler, so much safer, so much better to go to this new messaging system. So I hope you enjoy it and have a lot of fun with it.